first of our two interesting talks this morning. These are free Harvard talks brought to you to TMU. Dr. Leo is going to be giving this first talk, and I'm not going to introduce him again since you just heard about him, but his talk is going to be on artificial intelligence in medicine. So look forward to that.
Thank you. Okay, I'm gonna start off with funding disclosure. Our group receives money from Philips, Merck, Amazon, Microsoft, and SAP. And I'm gonna begin this talk by starting off with big data. Like a few years ago, the biggest buzz phrase really is big data. And I'm gonna summarize what we think is the role of big data in healthcare and actually quote a recent paper that was published in the New England Journal of Medicine from Tom Frieden. And he said that for much and perhaps most of medical practice, randomized controlled trial-based data are lacking. And no randomized controlled trial is being planned or is likely to be completed to provide evidence for action. It leaves practitioners, doctors, nurses, with large information gaps for most conditions and increases reliance on clinical lore. So these are the things that we hold dearly that's not substantiated by data. I'm gonna start off with providing the landscape of health data. In 2013, the world produced 153 exabytes of health data. And just to give people a reminder, 1 exabyte is 1 billion gigabytes. And we're expected to produce an estimated of 2,314 exabytes of health data in 2020. Last year alone, we've heard that there were 274 million data-generating wearable devices that were sold. And we think that this could continue to skyrocket. And that means there's going to be lots and lots of health data that will be captured as a result of the use of these wearable devices. Since 2011, around $2 billion has been invested to fund companies that offer predictive analytics in healthcare. And these are just some of the startup companies around, primarily Cambridge, Massachusetts, and the Silicon Valley. And industry analysts predict that 30% of doctors will use analytic software to interpret patient data by next year alone. So again, we're looking at increasing role of this prediction algorithms as well as AI tools to really help doctors inform decisions. But there's a big issue. Artificial intelligence really results from the data, and not just any data. Data that has to be integrated, data that has to be pre-processed, data that has to be made machine ready for the types of questions that we're interested in answering. So this is data coming from Deloitte. 4 in 5 organizations surveyed do not have an integrated strategy for using analytics. And this is true not just in the US, but around the world. 1 in 3 health systems report that they do not know their organization's total spending on analytics. And 1 in 4 health systems report that they do not have a data governance model in place. So one of the key messages that I want people to take away from this talk is that healthcare organizations will need to invest in the tools and infrastructure to manage data. Otherwise, all this promise of artificial intelligence and machine learning is not going to happen. So, as I said, 5 years ago, the big buzzword is machine learning. Now, we're hearing more and more about artificial intelligence. We read headlines such as how AI is transforming healthcare and solving problems in 2017. AI will redesign healthcare, and then to the concern of a lot of doctors, technology will replace many doctors, lawyers, and other professionals. But let's define AI first. I'm going to use a definition given by the late Marvin Minsky, who's one of the real pioneers of artificial intelligence. And he defined AI as the science of making machines do things that would require intelligence if done by man. Let's interrupt the talk for a bit. I'm going to ask the audience, who among you will hop on a plane that is flown by artificial intelligence? Show of hands. So this is a biased audience. So these are people who are interested in AI. But the message of this particular question is we're actually doing that right now. So who's flying the plane? When they interviewed Boeing 777 pilots, they said that they spend an average of 7 minutes for a typical flight actually flying the aircraft. The rest of the flight is actually being flown by computers. And this means like touching the controls. Airbus pilots fly their aircraft about half the time, so about 3.5 minutes. The rest of the time, it's computers flying the plane. For a 2.5-hour domestic flight, autopilot systems will do 95% of the work. And this starts off from about 1,000 to 2,000 feet after takeoff. And then the pilots really don't take over again until the plane is a few thousand feet above the airport. And the rest of the time, as I said, everything is autopilot. Flight management systems set courses, they switch navigation radio frequencies. So we think that these are tasks done by pilots, but no longer the case. They're done by computers. And the reason is that computers are less likely to make mistakes than pilots. It's funny, when I was talking to pilots, they were saying that the more severe the weather conditions, the less likely that they're going to fly the plane, because they just don't trust themselves. They trust the computers to be able to navigate through those severe weather conditions. And then in the last few years, even healthcare has not been isolated in terms of the advances that we've seen artificial intelligence in. So we've heard about artificial intelligence systems beating human experts in the board game Go, in Atari video games, as well as in poker. And then we've also heard about AI systems being able to produce handwriting and speech indistinguishable from those of humans. And we're all aware how Google Translate has become so much better in being able to seamlessly move from one language to another. And you can even transform your holiday pictures into the style of Van Gogh. And this is done through artificial intelligence. There's a software called WaveNet, and it generates speech which mimics any human voice. You could say, Barack Obama, say this. And it does that, again, just by listening to a lot of the speeches that have been done by Barack Obama. It synthesizes audio signals such as music, and it would present some striking samples of automatically generated piano pieces. In healthcare itself, there have been some landmark papers that were published last year. This one was published in JAMA, and it showed that machine learning algorithm could outperform eye doctors in identifying the complication of diabetic retinopathy. This is a complication of diabetes, and if you give the machine photos, it's able to classify whether there is diabetic retinopathy or not, as well as an ophthalmologist. Another paper from last year, this one got published in Nature, and this is about classifying photos of skin lesions. So Jack, your profession is in danger, but they found that the computer systems were as good, if not better, than dermatologists in picking up skin cancer if you feed it photos of the skin lesion. This is also being done in histopathology. So now we have computer systems looking through the slides and picking up whether there's evidence of cancer or even cancer outside the original site. But I'm going to warn the audience that it's all not good news. There are so much pitfalls of big data and artificial intelligence that we really need to be more cautious and thoughtful as we progress in this area. So the pitfalls of big data are no different from the pitfalls of statistics, except that they're magnified. And these are some examples that I'm fascinated with. Some of you may have heard them already, but it's worth going through them again. This is introducing the concept of researchers' degrees of freedom and p-hacking. So researchers' degrees of freedom pertain to how investigators or people who are performing machine learning would make small decisions along the way as they're performing the research. And all the decisions that they make ultimately would lead to the conclusion that they get at the end. So there are so many ad hoc decisions that they do as they try to answer a specific research question which would affect what they get at the end of the study. And p-hacking is a related concept. These concepts both originated from some psychologists from University of Pennsylvania. So p-hacking is when you repeat your analysis over and over again because you weren't happy with your result the first time. You change the definition of your outcome a little bit. You change the definition of your exposure a little bit. You add some more confounders, and you don't stop until you get a p-value that's statistically significant. And when it's time to report your finding, you don't report all the other analysis that you've done. You only report the analysis that agrees with your hypothesis. This is an exercise that was offered by 538, which is a nonprofit organization started by Nate Silver. And in this particular exercise, they provided the data about the US government and US economy. And the question that they invited the audience to ask the database is the US economy better when it's the Democrats leading the government or it's the Republicans? And they gave different variables to represent economy. They have the GDP, they have the unemployment rate, and then there are also several variables to represent the government. Is it who is sitting at the White House, who has majority in the Senate, who has majority in the Congress? And then there's a lot of different confounders in there. And they invite you to ask that question to see what the answer is. And if you're not happy with the answer, they invite you to change your definition of your outcome a little bit, to change the definition of exposure. You repeat the analysis until you get the answer that you want. In reality, this happens all the time. And this is going to get worse as we deal with big data. We're going to find the answers that we're looking for. This is another exercise. This came from the Center for Open Science. It's a group led by Jeff Spice and Brian Nosek, who are very passionate about improving the way we do research. And in this particular exercise, they gave 29 research teams data of international soccer games and all the instances when a referee gave a red flag to a soccer player is included in the database. And they had one question to ask the research team. Are the referees biased? Are they more likely to give red flags if it's a colored player or not? And you would think that it's the same database, that 29 research teams are experienced in terms of doing data analysis. You would think that they will have the same answer to the question, are referees biased? And of course, they did not. They all used different methodologies, and you would see here effect sizes that are all over the map with different confidence intervals. In the end, what the group from UVA did was to sort of do a meta-analysis. They combined all the analysis, and they said that the referees are probably biased, but the effect size is actually not that large. And that's the reason why we're seeing all this random, almost distribution of the answers that they got. And finally, one of my favorite projects that was published in 2011, this is the Dead Salmon study. So Dead Salmon study looks at functional MRIs. And if you're familiar with functional MRI studies, you do lots and lots of MRIs. You expose the subject to a certain task or a certain image or video, and you see which parts of the brain are lighting up with respect to a certain emotion. So now you are able to identify which parts of the brain are associated with depression or happiness or anxiety around social situations. But as in other studies that do multiple comparisons, you're going to see a lot of false positives. You have to adjust for the number of comparisons that you do. And in this particular study, what they did was the investigators bought some salmon, dead salmon, at the beginning of the day. They started showing the dead salmon's pictures of negative social situations, and they started doing fMRIs of the dead salmon. And true enough, they were able to find some parts of the dead salmon's brain lighting up when the dead salmon was shown photos. And again, their message is that unless you do adjustments of the way you're doing your analysis, you will find false positives. And that's really the big problem with big data. Another issue that we're confronted with is majority of the algorithms that you are going to be using, say for example, the algorithm that allowed us to classify the photos of the back of the eye to see whether the patient has a diabetic retinopathy, or even the algorithm that will classify a skin lesion of whether it is cancerous or not, they're black boxes. You don't know how the algorithm was able to arrive at a decision. So this is one of the biggest issue with AI now, is what's inside the black box. And a lot of doctors and nurses are not ready to accept any algorithm that they don't understand. So interpretability, why do we need to have explainable artificial intelligence? There are several reasons that I'm going to highlight in this talk. First is that the ability to explain the rationality behind one's decision is an important aspect of intelligence. If you cannot explain why you did this, typically you're thought of as not being too bright. Also, not just too bright, but you're probably not trustworthy. A person who does not reveal his thought process is considered not trustworthy. And for doctors and nurses, this is going to be problematic because trust is such a basic element of our relationship with our patients. And lastly, understanding of what happened or understanding how an algorithm works is really crucial for learning. So we're not going to learn if we just accept any black box algorithm. And there are now a movement towards making AI more transparent or understanding how the algorithm is providing decision. So persons affected by decisions from AI system may want to know why the system decided that way. And in Europe, they're adopting new regulations which implement a right to explanation. So say, for example, if you were denied a loan because the bank used an algorithm and said that you won't be able to pay your loan, the user can demand for an explanation of why the bank, so the bank has to explain somehow how it reached that decision that you won't be able to pay your loan. There are now tools that you could use to improve the interpretability of machine learning tools or AI tools. Here I just highlight two. LRP stands for layer-wise relevance propagation, and the other one is on sensitivity analysis. And these are primarily used in image recognition. So say, for example, you have a picture there and you want to know what's in the picture, and it goes through a black box AI system, and the black box AI system says, this is a rooster. And you apply these two methodologies where it would actually look at what pixels were most influential in terms of making that decision. And it's able to produce a heat map. So here, the pixels on the upper right-hand corner are the ones that have the most weight in providing this particular classification. And these two methodologies in terms of improving the interpretability of AI is being used not just in image classification, but they've used this for text document classification as well as in human action recognition in videos. And finally, one of the reasons why we need to understand what the AI system is doing is because this is the only way to understand whether bias has been introduced or whether there's a flaw in the algorithm itself. This was a big news last year. It was a paper that was published in ProPublica, and it talked about machine bias. So across the courts in the United States, they're now using AI in terms of helping the judge make decisions about the person who is being trialed. So it helps the judge make decisions about bail. It helps the judge make decisions about whether this prisoner is worthy of being paroled. Is he going to repeat the crime again if he gets released? And when they looked at the accuracy of that system, it turned out that the formula was particularly likely to falsely flag black defendants as future criminals, wrongly labeling them at almost twice the rate as white defendants. And white defendants were mislabeled as low risk more often than black defendants. It turned out that the algorithm was very biased against black people. And when they looked at why did that happen, it turned out that there were not enough black people who were do-gooders in the original database. So that when they had the algorithm, it just looked at black people and it just looked at the black people in the system who repeated the crime. So there is a big risk of human bias being magnified by the machines. So this is it's not really machine bias because it actually reflects and mirrors the human bias. And lastly, there was so much panic and confusion during summer when we saw these headlines. Facebook engineers panic, pull plug on AI after the bots develop their own language. And this is the actual phrase that made the people panic. So these are two chatbots that were talking to each other. The chatbots were being developed to be able to talk to humans, but also to be able to talk with each other. And then they started seeing all these weird things that we don't understand, and we thought that these bots are probably talking about us, plotting the next Skynet and the destruction of the universe. But it turned out to be not that way. There was a lot of sensationalism. So as I said, these chatbots were designed to negotiate with each other, but the programmers made an error by not incentivizing the chatbots to communicate in human comprehensible language. And what they only did was that the bots began chatting back and forth in the derived shorthand. So this is just coming up with some shortcuts to be able to express something else. So it's not like they suddenly have their own self-awareness and they could talk to each other and they could plan something outside what the programmers had intended them to do. So this is one of my last key messages. The pressing ethical questions in machine learning are not about machines becoming self-aware and taking over the world, but about how people can exploit other people or through carelessness introduce immoral behavior into automated systems. I keep saying it's the last one, and I realize there are 3 more slides. One more message. People always think that as we go to precision medicine, as we sift through more and more data, we think that we're going to have exact answers. We're going to know definitely what's the best treatment for a patient. But it's the opposite. As we go into precision medicine, we will not eliminate, but we will actually increase uncertainty. Then, isn't that counterintuitive? Why are we going there when, in fact, we are more exact now? Well, the answer to that is, we think that we're more exact now, but we're deluding ourselves to think that we know the best decisions for patients. For the longest times, we have been arrogant to think that we make the best decisions for every patient, but in reality, we're mistaken a lot of the times. And the data is going to help us really try to improve the way we make decisions for our patients, or we share that decision process with our patient. This is a great piece that came from my colleagues actually at Beth Israel Deaconess, from Rich Schwartzstein and Arabella Simpkin. They're talking about tolerating uncertainty as the next medical revolution. As doctors, we were never trained to think in probabilities. Our exams are all true or false, multiple choice, as if there's a correct answer. In medicine, typically there's no correct answer. It's the answer that's most in line with the preferences of the patients. That's really the correct answer. In this particular piece, Arabella and Rich said that patients struggle to interpret the most dire forecast, often assuming that 90% mortality means a 10% chance that life will be just as it was before, even when life as usual is simply not possible. And even we raise the existence of uncertainty, typically we don't assist the patients on how to address the uncertainty. Doctors fear that by expressing uncertainty, they project ignorance. I boldened the next point in red because I really think that the value of doctors in the future is not about synthesizing data or making sense of the data. I think the computers will make a much better job of doing that. Our role will be to support the patients in navigating through uncertainty, asking them for their preferences, what is it that you value more? Is it this specific loss of function, or is this small probability of extending your life? There is a strategy called scenario planning. It came from Pierre Wack, who was an economist from Shell, and it talks about accepting uncertainty and using it as a part of reasoning. So rather than emphasizing precise predictions, you are gonna die or you're gonna be on dialysis for the rest of your life, the technique generates multiple possible features. You actually give different scenarios. The aim is not to present the correct scenario, but to describe a range of stories illustrating how the future might unfold. An editorial from British Medical Journal from Stephen Hatch, just across the river, Tufts Medical Center. Admission of uncertainty forms a starting point for a more open conversation. And by being more direct about uncertainties, doctors are likely to foster greater trust in their efforts to manage the patient's condition. So from Harvard Business Review, the new SMART will be determined not by what or how we know, but by the quality of our thinking, listening, relating, collaborating, and learning. Just to wrap it up, the breakthroughs in AI are a result of the three factors: the availability of large databases, the gains obtained with powerful GPU cards, the high flexibility of software frameworks such as SCAF or TensorFlow. I want to highlight the availability of large databases. I think some of you will be using the Mimic database during this datathon. At the start of the year, we also released a Philips database of ICU patients coming from across the United States, ICUs across the United States. But these two public databases are not enough. We need to have database coming from Taiwan. That's the only way we would improve the way we deliver care in Taiwan, is if we could learn from the real world data that's being collected as Taiwanese patients are cared for here in our hospitals and clinics and at home. So last slide, I promise. For a true health data revolution to occur in healthcare, we must become better at sharing and integrating data. Greater emphasis on collaboration outside the traditional multidisciplinary realm and into the engineering, mathematical, and computer sciences will help us to achieve this. Thank you very much. This is a datathon. I'm inviting you. It's next month in Beijing. Let me know if you're interested in coming. And please visit us on our social media page. Please post photos as well. Thank you.
Thank you, Leo, for the sobering talk about AI. It's great to see that, you know,
We have few minutes.
critical, huh?
We have few minutes to take questions.
Oh, we have a few questions. Oh, we have a few minutes for questions, so I'll let you take, please ask some questions. Yes.
I'm Mark Lin. I also come from Jack's department, and I'm also a neurosurgeon. Actually, I teach the clinical decision support class. It's kind of traditional AI class. And there's a quote from a textbook, Clinical Decision Support by Rob Green. I always tell students that the AI or the clinical decision support, the computer won't teach us the new thing, because like the reminder, the alarm system, they do a survey that the system, the computer only just remind you something, they won't teach you some new thing. But start like this, the AlphaGo development of the AI. So I start wondering whether I need to change my tone about this, and what's your thing?
So I think that the biggest contribution of computers is that they don't have the same cognitive biases, or they don't have as much cognitive biases as we could. And we could spend hours and hours talking about cognitive biases. So we could have an evidence there, but the way you process that evidence and apply it to your patient is affected by your experience last night, or whether you're tired on that particular minute or not. And those are the things that we really want to try to reduce as much as possible. And I think machines will have, are going to have less cognitive biases compared to humans. But as I said, I completely agree with you. There's nothing new that we're gonna learn. I think what we're gonna learn more is how much cognitive bias we have. When you start comparing my decision versus the machine's decision, I tell my residents and fellows, you probably should follow the machine's suggestion, because at 2 a.m. in the morning, I'm sorry, but I couldn't rely on the way you're able to integrate data when you haven't slept in the last 24 hours. I'm more confident about the machine being able to integrate the data and being able to come up with the best recommendation for this particular patient. Any other question?
Okay. Yeah.
Good morning. It was like really good presentation. I am like a professor here, and I'm working on smart technologies. I am working on a MOOC on smart technologies for cancer management, and where I want to use chatbots And what do you think, how precision we can get information from chatbots if we integrate the database to the electronic health records of the patient?
So I have a whole talk about chatbots actually, where it was shown that patients are actually more comfortable talking to chatbots. They are able to express their emotions more intensely when they. So there was this experiment where they divided the patients into two. One group, they said that the virtual doctor that you're talking to is actually a computer. And another one, it says that the virtual doctor that you're talking to is actually another doctor, but he won't know that he or she is talking to you because they anonymize it. So they change the voice and they change your form. And then when they compared how the patients were reacting to the chatbot versus to another human, it turned out that they were reacting to the chatbot better. So I think this is one field where we're going to have tremendous progress in the next few years, is the use of these chatbots and even text messaging in terms of enriching the interface of the patients with healthcare.
Okay, then I want to follow, if I have some time. Next follow-up question.
Yeah, I think because we're supposed to run until 11:15.
Okay.
We're 11.
Oh, 11.
Yeah, okay. It will be last question from my side. It's about artificial empathy, because now Professor Lee is working on AIM-HIGH, that is artificial intelligence in medicine and health innovations, where we want to build artificial empathy for the machine. So you think how far it goes?
Well, it's funny because I've met a lot of doctors and nurses who actually don't have empathy. So I think any artificial empathy would actually be good in terms of someone who would actually ask, how do you feel? Because I've worked with doctors and nurses who wouldn't even ask the patient how do they feel. Like, this is what you need to do, this is what I think is best for you. I couldn't care less what you think about this. So I think, I mean, it will go a long way if there's going to be some programming to be able to provide empathy coming from machines. And again, it's learning from the doctors and nurses who have the best empathy. Maybe that could be learned by computers and robots.
Thank you.
Thank you.
Yeah, we have time, right?
Yes.
Okay, just one more question about the diagnosis. I think from a project called the Human Diagnosis Project, they computed or they estimated that 20% of the diagnoses are actually wrong. Medical diagnosis made by medical doctors. So what do you think AI or whatever is coming next, smarter system, is going to actually change that, or is going to actually make it worse?
No, I think diagnosis is one of the areas where the computers are going to take over. Because again, when we listen to the story of a patient, you anchor on the words that you relate to, or that are already reinforcing what your original theory is. Machines don't do that. They don't tend to really latch on to a few parts of the history. I think diagnosis is in the future really going to be taken over by the machines. There was a study looking at listening for the third heart sound, S3, and we were pitiful in terms of the inter-rater operability, in terms of what we think is the sensitivity specifically of S3. Again, as you amass more and more data, I think the machines will have a better really way of extracting the information that is needed for the decision making. Again, I think we will be focused on the touchy-feely role as doctors and less in the thinking part. Okay, thank you, Richard.
Okay. Thank you.